Okay, pre-calc students, in these videos I'm going to work through all of the problems in the review assignment. You should actually attempt the entire assignment before watching the video. So if you haven't done that yet, stop the video and save this for later. After you've completed the assignment and checked your work with the key, if there are any problems you're not understanding, you can watch the videos and just fast forward to those problems and see them worked out step by step. In problem 1a, we're finding f of 4, so we need to substitute 4 for the x value. So 2 times 4 minus 7 is 8 minus 7, which is 1. In g of 2, we're using a new function. We're using g, and we're substituting 2. So we have 3 minus 2 over 2 times 2 plus 4. So our numerator is 1, our denominator is 4 plus 4, which is 8. In C, we're doing the same thing, but we're substituting the whole expression b squared minus 1 for all of our x's. So the function f is 2 times x minus 7. And instead of the x, we're putting in b squared minus 1. So you need to distribute the 2. We have 2b squared minus 2 minus 7, and combine like terms. Okay, now we're composing functions. We're going to do f of g. So our outside function is f. That means 2 times something minus 7. And now g is our inside function. It goes in place of the x in the function f. So we're going to put g inside 3 minus x over 2 x plus 4. Now we may be used to distributing this 2 to the numerator like this, and then we would have 2 times 3 and 2 times x. But if you notice, our denominator already has a common factor of 2. So to get this in its simplest form, instead of distributing, what I'm going to do is factor the 2 out of the denominator. Let's fix that. 3 minus x. I'm going to factor the 2 out of the denominator and cancel it out, and that will give me the fraction in its simplest form. So I'm going to keep the 2 out here. I still have 3 minus x in the numerator. My denominator is 2 times x plus 2. Now it's not wrong if you did it the other way, but it would require more work in the end because you do want your simplest answer possible. So those 2's cancel out. I have 3 minus x over x plus 2. Now I still have a minus 7 over here, and I want to be able to combine that with my fraction. So I need to get a common denominator of x plus 2. So I'm going to multiply the 7 times x plus 2 over x plus 2. Distribute the negative 7 to each term. And now I have a common denominator, so I'm going to make this all into one fraction over x plus 2. I still have 3 minus x from the first fraction, and I also have minus 7x and minus 14. So my final answer, after I combine like terms, I have negative x minus 7x, that's negative 8x, and I have 3 minus 14, that's negative 11, and that's all over x plus 2. Now in my domain, I'm going to have to leave negative 2 out of the domain because that would make this denominator here 0. So I'm going to write x cannot equal negative 2. I also need to look at the domain of the inner function, and my inner function was g. The denominator of g is 2x plus 4. So if I set that also not equal to 0, I again get x does not equal negative 2. So I don't need to write anything more for my domain. In g of f, my outer function is 3 minus x, so that's something, over 2 times something plus 4. And then my inner function is f, so that goes everywhere where g had an x. So I'm going to put 2x minus 7 and 2x minus 7. Now remember that when I'm subtracting this entire function, you need to distribute the subtraction to each term. So in my numerator, I have 3 minus 2x plus 7. In my denominator, I need to distribute the 2 to each term. So that gives me 4x minus 14 plus 4. And now you need to combine like terms in numerator and denominator. I have negative 2x plus 10. And I have 4x minus 10. Now notice your numerator and denominator both have common factors of 2. So you want to factor that common factor of 2 out so that it can cancel. So I have 2 times negative x plus 5 and 2 times 2x minus 5. And these two cancel, and my final answer is negative x plus 5 over 2x minus 5. So I have to set my denominator not equal to 0. 2x minus 5 doesn't equal 0. That means that x does not equal 5/2. My inside function is 2x minus 7, which is a linear function, and that has no restrictions. So my only restriction here is that x does not equal 5/2. Okay, to find the inverses of these functions, I need to switch the x's and the y's. So for the f function, I switch the x and y, and I get x equals 2y minus 7. To solve that for y, you add the x, you add the x plus 7, and then you divide by 2. And then you want to use your inverse notation. So inverse of f equals x plus 7 all over 2. To find the inverse of g, it's a little bit more complicated because it's a rational function. You still start by switching the x and y. So I have x equals 3 minus y over 2y plus 4. I'm going to multiply both sides by 2y plus 4 to get it out of the denominator. So essentially, I'm multiplying 2y plus 4 times the x, and that x distributes to each term. So that's going to give me 2yx plus 4x equals 3 minus y. Now you want to get your y's together, so I'm going to add y to move it to the left. 2yx plus y. And I'm going to subtract 4x to move that to the right. So that's 3 minus 4x. My y's are on the same side. To separate it from everything else, I'm going to factor it out as a common factor. So I'm going to factor out the y. I'm left with 2x plus 1. That still equals 3 minus 4x. Now you can divide both sides by 2x plus 1. And then use your notation. Inverse of g equals 3 minus 4x over 2x plus 1. And I'm going to stop the first video here. You'll continue on a new video.